Okay, so in this video we're going to do a couple of examples of finding the inverse or the graph of an inverse function given a graph. And then the second example we're going to do is what if we have a restricted domain? How does that affect how we find and how we write the equation or the function of the inverse function? Okay, so here we go. So in example 1 we're given a couple of graphs. Okay, and so these are f of x. So this is the graph of f of x here, and this is the graph of f of x here. And so what we're going to do is we're going to use what we know to find the inverse of the graph of the inverse function. So one thing is you can plot the inverse, the points on the inverse. So notice that this ordered pair is -4, 0. And so if we interchange those, well, we get 0, -4. So if we go 0, -4, that's going to put us down here. Okay? And if we look at this point here, 3, 1, and we interchange those two coordinates, and we get 1, 3. So 1, 3 is right here. Okay? And so if we plot those 2 points, we get inverse, and this will go blue. Let's see. Okay, and so this is f inverse, and so we used the first method by just taking points on f and interchanging them to find points on f inverse and then plotting through those points. But also notice that, and again, don't take my graph. Don't take my graph, my artistic skill notwithstanding. So if I plot the basic function, this is y equals x, our identity function, okay, that you notice that it is symmetric. Again, my graph, my artistic skills notwithstanding, it is symmetric with respect to the y equals x. So I could have done is, now again, the second method isn't the most ideal method because how are we going to plot by symmetry? It's going to be more difficult, but that's one way of doing it. But the first way is going to be probably the better way of doing this thing. Okay, so this is how we use the method of graphing. Okay, now let's look at this one. Actually, let's call this A. We'll call this B. So let's go to B. Now again, if I go through, right, and I plot the x equals y, then this point should be the same distance from this line as this point. Okay, so if I go the same distance from this point, that should put me on the mirror image. So basically plotting inverse functions, if you're given the function, is about finding the mirror image of the function across the y equals x line. Okay, that's basically what we're doing. But again, it's difficult, especially when you're sketching the graph, to use that method. So what we're going to do is, again, I'm just going to interchange. So this one is 1, 1. Notice that 1, 1 stays the same. And notice that it's also on the y equals x line. So we got 1, 1. And here we've got 2, 2, 4. And of course we have y equals x. And so if we use the same method, we say, okay, well, let's interchange the 2 points. So 4, 2 is going to be right about here. And if you look at that, it does sort of look like it goes straight across. Not exactly because of my drawing, but it should be straight across, same distance from the red line. Okay? And so if we use this to plot, we get something that looks like that. And so look, notice how this is a mirror image across y equals x. And again, this is a mirror image across y equals x. Okay? So that's example 1. Okay, using a graph to find the inverse graph. Okay, now example 2. What if we have a restricted domain? Like for example, in this example, we have f of x equals the square root of x plus 5. And so we know that because it's a square root, we can't have any negative numbers under the radical. So that means, in this case, x has to be greater than or equal to negative 5, which is what we have here. Okay? Because we know this has to be non-negative. Okay? Which makes the range of f of x equal to what? Well, remember, it has to be non-negative. So when this is equal to negative 5, you get 0. And if anything bigger than negative 5, you get something positive. So this is going to go from 0 to positive infinity. Okay? So the domain is this. The restricted domain is anything greater than or equal to negative 5. And the range of this function is from 0 to positive infinity. So let's go through the steps of finding the inverse function. So again, the 4 steps is first we're going to replace f of x with y. So we're going to use y equals the square root of x plus 5. And then I'm going to interchange x and y. So I'm going to write this as x equals the square root of y plus 5. And then I'm going to solve for y. So again, I'm going to square both sides. And so I get x squared equals y plus 5. And then I'm going to subtract 5 from both sides. And I end up with y equals x squared minus 5. Okay? Now normally we would be finished and we'd be done at this point, but we're not. Because remember, this function, let me get to the last step. This inverse function is not defined for all values of x, even though normally it is, right? This is okay for all values of x, but remember, the domain and the range of the function switch when you're talking about the inverse function. So the domain of the function becomes the range of the inverse function. And the range of the function becomes the domain of the inverse function. So, if we go back to this, we know that the domain of this function is what? Greater than or equal to negative 5. Okay? And the range of this function, as we discussed, is from 0 to positive infinity, which means that range has to be this domain. So the restricted domain for the inverse function must be greater than or equal to 0. Okay, so again, we got to make sure we pay attention to that because that's important. Okay, so this inverse function is only defined for all values 0 to positive infinity. And that's it. Till the next time, have a great day.